The greatest limiting factor of Mars human exploration is radiation. Long-term exposure to radiation can have deleterious effects on humans and can ultimately lead to cancer and cell damage. Radiation is released from three major sources. The first source, trapped belt radiation, occurs from molecules found in the Earth's magnetic field. The high-energy electrons and ions circling the Earth comprise the majority of radiation from this source. The second source is galactic cosmic rays, which consist of particles that originate outside the solar system. They are typically supernova remnants and travel within the Milky Way galaxy. The third source is known as a solar particle event, which essentially refers to solar flares. These flares are the most potent space radiation hazard because there is no natural shield to protect astronauts from these. Also, although the atmosphere of Mars will block out some of the radiation, it does not block out as much as Earth's atmosphere. The radiation that an astronaut would experience on a 500-day round-trip Mars mission would almost guarantee cancer, if not be on the edge of the range for lethal exposure. Therefore, radiation is an omnipresent problem in space exploration and must be accommodated for. Since radiation is a natural occurrence and cannot be stopped or prevented, it is imperative that safety measures are utilized to ensure the safety and health of our astronauts. The first safety measure that must be taken is on the vehicle used for transportation from Earth to Mars. Although there are already some shielding and sheltering measures in place to protect crews from radiation, a manned mission to Mars will require much lighter materials to allow for the longer mission. Since using lighter materials will be far too expensive, a possible solution is to create a storm cellar type of location in the middle of the vehicle to shelter the astronauts for several days during the periods of high solar activity. This shielded location will be surrounded by water tanks to create more protection for the astronauts. During the time spent in the storm cellar, the crew will have to be able to live in small amounts of space. Not only do the crew members need to be protected from the radiation, but also the computers and software components of the vehicle must be protected as they contain crucial elements to the mission's success. People at Mission Control will be crucial to alleviate the radiation problem by relaying information regarding the activity of the sun and coronal flares to the crew. As another countermeasure to radiation, supplementing an astronaut's diet with antioxidants such as vitamin E and C will be helpful in warding off the effects of radiation. Also, bone marrow samples could be selected from the astronauts prior to flight to allow for the regeneration of immune system cells in the event of the development of cancer. As a result, radiation is one of the most important factors, if not the most important factor to consider when planning for human Mars exploration, as this issue will be present throughout the entire mission.